Okay, for our final example of a strong induction proof, we're going to go back to a little number theory statement. It says, prove that 6 divides n cubed minus n for all n greater than or equal to 0. So for any non-negative integer. So we're going to look at, well, first we're going to do the base case. And because I've worked this out before, I know I'm going to need 2 base cases, because we'll see I need k to be at least 1. So the base case, I'm doing n equals 0, n equals 1. Well, notice in both cases, if n is a 0, you get 0 minus 0, and if n is a 1, you get 1 minus 1. And 6 divides 0. Every number divides 0 because there is an integer I can multiply 6 by to get 0, namely 0. Base case was easy. Okay, so now to do the induction portion, strong induction, suppose the statement, it's just this statement, holds for all values of n going from 0 and 1, which we proved, all the way up to k. So again, I know k is at least 1. So I can go back and look, I can look back to k minus 1 if I want to, no matter what k is. If it's true for 0 to k, I know k minus 1 is also true. It would not be the case if we had not proven 1 and k could be 0, I would not be able to go back because there is no negative 0 case. So by doing 0 and 1, I know that we're going to assume k is true and k minus 1 as well. From 0 all the way up to k. So we're going to prove the k plus 1 case. What is that? Replace n in both places with k plus 1 in parentheses. So we need to prove that 6 divides k plus 1 cubed minus k plus 1 in parentheses. So note, I'm going to start off this note. Since the statement holds, that means it's true, for n equals k minus 1, I know, or we know, that 6 divides, now I'm able to go, instead of k plus 1, k minus 1. K minus 1 cubed minus k minus 1. The only reason I can do that is I'm allowed to plug in any number from 0 all the way up to k, and I know it's going to be true because we're assuming that's true. K minus 1 is less than k. It's this number right next to it, to its left. So I know that 6 divides this. The statement holds for everything up to k. That's the k minus 1 case. So now I can say, let, by definition of divides, that means 6 times some integer gives me this. Let 6t equal k minus 1 cubed minus k minus 1. Okay, so let's continue. Now I want to prove that this is divisible by 6. I need to prove that 6 times something gives me this. So I'm going to write that down. I'm going to write I'm going to write k plus 1 cubed minus k plus 1 equals, and I'm going to do a whole bunch of arithmetic, algebra, and I'm going to end up with this equals 6 times some integer. And we will be done. All right, well, let's notice that I'm just going to do a little bit of rearranging. I want to get something that looks like this, because I have this formula that 6t is equal to this. So if I were to take k plus 2, k plus 1, and subtract 2 and add 2 to make no difference, I would get a k minus 1 plus a 2. And that's what I'm going to do for starters. K minus 1 plus 2 cubed. That's equal to this, because this is just k plus 1. Minus, I'll use square brackets again, k minus 1 plus 2. So I've done nothing but added and subtracted. I mean, if you add 0, you haven't changed anything. I subtracted, this was a 1. I subtracted 2 and added 2 to get this. This was k plus 1. I subtracted 2 and added 2 to get that. All right, so this is equal to, and this is where I'm going to use the binomial theorem. Maybe I'll make a note right here. To cube this, now we have 2 terms. We know how to cube a plus b. I'm going to get k minus 1 cubed times 2 to the 0, and I won't write that down, plus 3 times k minus 1 squared. Now I need a 2, because that's 2 to the 1, plus 3 times k minus 1 2 squared, plus 2 cubed. That is just this portion of it. Maybe I will underline that and that. Those two things are equal, and now I need to work on the part on the right, which I'm just going to rewrite. I'm not going to make a change. I'm just going to say minus k minus 1 minus 2. I removed the brackets, so it's minus this, minus 2. Okay, for the next one, I'm going to get k, let's see, what do we have? K minus 1 cubed, and I want to lump it together. Remember, I want something that looks like this, so let's make it happen right now. K minus 1 cubed, and I have a minus k minus 1 right here. So I've taken care of that one and that one. And I think I'll put, just to delineate it, I'm going to put brackets around it. So the two things I scratched out are this right here. And now I've got the remainder of the stuff. So how many, what do I have here? I've got like terms. I've got k minus 1 squareds here and here. How many do I have? I've got 6 right here. And is that all I have? 3. Oh, I'm sorry, these are not like terms. What am I talking about? This is all by itself. That's 6 k minus 1 squared. Just multiplied the 2 times the 3. And then 2 squared is 4 times 3 is 12. So I'm going to get a 12 times a k minus 1 in parentheses with the k minus 1. And then we have constants. 2 cubed is 8 minus 2 gives us 6. So work through that again. Make sure I got that correct. Well, we'll find out in a minute. Excuse me. Well, this looks like it's pretty easy from here on out. What is this in brackets? 6t. 6t, right? Plus 6k minus 1 squared plus 12k minus 1 plus 6. Factor out the 6. T plus k minus 1 squared plus 2 k minus 1 plus 1, and we are done. We showed that this, which is the same as this, is equal to 6 times a number. Therefore, we've shown that 6 divides that. And maybe I'll write that down with a different color. That implies 6 divides, well, I'm rewriting this. K plus 1 cubed minus, in parentheses, k plus 1. Hopefully you can see that. And that is the end of the proof.